Composition of functions. A composition is going to be placing a function inside of another function. So the composition of functions f with g is denoted f, and you see the open zero? That is composition. That's what it means. Where the closed circle, that is indicating multiplication. So try not to let those confuse you. A lot of times I see people get a little confused and they see that and they try to multiply the functions. This means composition. So the composition of functions f with g is denoted f at 0g. So f composed with g is defined by the equation f composed of g, or f of x with g of x inside of it. The domain of the composition function is a set of all set of all x such that x is in the domain of g and g of x is in the domain of f. So we're going to try to make this a little easier on you. But go back to what we had reviewed about rational equations. Because a lot of stuff about domain with rational equations will help you here. So given fx is equal to 5x plus 6, and g of x is 2x squared minus x minus 1, we want to find f composed with g of x. So a lot of people call this the fog function, but all it is I'm just taking f and I'm placing g inside of the function. So a way to think about this is, if you remember function notation, if I said f of x was 5x plus 6, well, that meant that f of 1 was just 5 times x is now 1 plus 6, which that's how we use to find a function value. But also I can replace f with other things. I can put t in there. So I can have f of t. So instead of having 5x plus 6, I have 5t plus 6. I could have f of x plus 1, which means that now I have 5. So instead of just x, I have 5 times x plus 1 plus 6. So with function notation, whatever I put in here replaces that x. So if I have f of g of x, that means I now have, instead of 5x, I have 5g of x plus 6. Now we know what g of x is. G of x is 2 squared minus x minus 1. So this is my composition. And everything I do after that composition is simplifying. That is 10x squared minus 5x minus 5 plus 6. So it's going to be 10x squared minus 5x plus 1. Now, as far as domain goes, the domain of x is all real numbers, and the domain of g of x is also all real numbers. So what we want to make sure is everything that goes into G works in F. So everything G is everything in the real numbers. So all X values in the real numbers work here. Then I put it into F. So all my outputs also have to work in F. Is a way to think about it. Or you could just look at this function here and go, okay, what is the domain of this function? After the composition, my domain is all real numbers again. So like I said, don't worry about that, trying to figure out what works in G and then if those outputs work in F kind of thing. Just look at your new function to determine the domain. But this is my composition function. So we can switch this and we can do G and composed with F. So if I do G composed with F, what that means now is that I'm going to have G and the function inside is F. So always think about this as this is going to be outside function. And then the second one's always inside function. So we're putting f inside of g. So in this case, this is my g, so g is 2. Instead of x, we have 2 times f of x minus f of x for the replace the other x minus 1. So all my x's are now placed with f of x. So we know that f of x is just going to be 5x plus 6. This is 2 times 5x plus 6 minus, parentheses, 5x plus 6 to replace this x, minus 1. You could say this is 10x plus 12 minus 5x minus 6 minus 1. So I have 10x squared. Let me go back there a second. That was 10x squared. So that's what we have. I'm like, oh, that was way too easy. So if we expand, we have 2 times 5x plus 6 times 5x plus 6. And then this negative distributes, so we get -5, -6, -1. We do this expansion. 2 times 5 times 5, so we're going to have 25x plus 30, so that's going to be 60x plus 36 minus 5x minus 7. Distribute my 2, I have 50x squared plus 120x plus, let me see, that'd be 72 minus 5x minus 7. So I think my final form here, we have g composed with f going to be equal to 50x squared plus 115x plus, let me see, that should be 65. There we go. Once again, if you're trying to find the domain, we don't have any radicals, we don't have any denominators to worry about, or x in a denominator, so it's all real numbers. So if you take a moment, we have the functions f of x is 2 over x minus 3, and g of x, which is x squared minus 3x plus 5. And we want to find f composed of g composed with f, and f composed with f, which we can compose a function with itself. And after you do that, we'll go back and we'll talk about the domain, even though I don't ask them for them here. Okay, so if we do the first one here, this means f is on the outside, g is on the inside. So f is just 2 over x, which is now g of x, minus 3. So we have 2 over x squared minus 3x plus 5 minus 3. Because this is all g of x right here. So that is going to be 2 over x squared minus 3 of x plus 2. Okay, so here we didn't simplify anything. We didn't eliminate any factors. So we're just going to try to find our domain. We're just going to figure out where the denominator is 0. So if you took this would simplify down into 2x You know what? Oh, there we go. I know it is x minus 2. I was going to say it doesn't, we're good. No, here we go. It would break down into x minus 2, x minus 1, because if you multiply those, you get the positive 2, and get the -3. So the things that are taken out of my domain, the x cannot be 1, and x cannot be 2. Because if it's 1, then we get a 0 in the denominator. If it's 2, we get a 0 in the denominator. Or you could say the domain is all real number, or not all real numbers, negative infinity up to 1, then from 1 to 2, and then from 2 to the other half of infinity. Now, if we compose it the other way, now we got G is on the outside, so decompose with F, G outside, F inside. We're going to have this little fun thing here. So G is going to be, remember all my x's are replaced with fx, so I have f of x squared minus 3 times f of x plus 5. And f of x is just the 2 over x minus 3. So we get 2 over x minus 3 squared. Minus 3 times 2 over x minus 3 plus 5. And if we try to simplify that, we are going to end up with a 4 over, so 2 times 2 squared is going to be 4. Squared of x minus 3 is going to be x squared minus x plus 9. This divides into, is just instead of 2 over 3, x minus 3, it's going to be negative 6 over x minus 3 plus 5. And we saw from here to here, the only thing you can't have in the denominator is a 3. So my domain would just be x goes from infinity up to 3. And then we skip over 3 because if we keep 3, then we have a 0 in the denominator. Yeah, our very last one, F composes F, means we're going to put F inside of F. So we're going to have F is going to be 2 over F of X minus 3, which is then going to be 2 over X minus 3 minus 3. Okay. So if we worry about the domain here, we just want to make sure that we don't have a 0 in the denominator. So we're only going to be worrying about out of the domain is we just need to make sure that we don't have that 3. Because that's the only thing we have to worry about, because this 2 over x minus 3, that's not going to equal 0. Because the only time anything can equal 0 is when this x is equal to 3, then we're dividing by 0, so we're undefined there. The only place we're undefined is when x is 3. So from here, at this point, if we want to simplify, because remember, we first find the domain when we have a bunch of rational expressions, and then we simplify. So what we could do here is, because we have this x minus 3 in the denominator, we're just going to multiply the top and the bottom by x minus 3 to clear the fraction. So we have 2 times x minus 3 over, if we distribute here, that's just going to leave me with the 2. And if I distribute here, that's going to leave me with negative 3 times x minus 3. So we're going to end up with 2x minus 3 over 2 minus 3x plus 9. Ultimately, this simplifies down to 2x minus 3 over minus 3x. Yep. Just make sure I have that plus 11. So going back with the main, so the following values must be excluded from the input x. If x is not in the domain of G, it must not be in the domain of the composition of F composed with G. If any x for which G is not in the domain of F, that also must not be in the domain of F composed with G. So that's another way you can do it, is you just sort of look at G and see, what do I remove? And then see what I need to remove from F and what in G would cause that. So we're kind of doing that same thing. It's just, like I said, if we want to do this the easy way, would be find domain before you simplify. the composition. So whatever your composition is, the best probably way to do that, and it's not you cause me any problems, is that if you find the domain before you start to simplify your composition, you'll know what your domain is of the new composition function, which is what we've been doing. So we want to just find the domain for this composition here. So here, my domain for G is X can't be 0. Here, my domain for F is that X cannot be -2. So what that means is that what needs to be removed from the domain when we do this composition is I need to know is when does 1 over X equal -2, because I have to remove it from this domain. So this would happen if X was equal to -1/2. So what we're going to find here is that when we do the domain of the composition, the domain should be all real numbers except that we can't have -1/2 and we can't have 0. So let's see what the composition looks like. So we're going to have f of g of x. That means if I do f, that's going to be 4 over, all my x's are replaced with g of x, so g of x plus 2. And we know g of x is 1/2. So it's going to be 4 over, not 1 over, I want 1 over x plus 2. So instead of doing the work that I did up here to figure out what that domain is, another way I could have done it is this. I need to know when does 1 over x equal 0, and I need to know when does 1 over x plus 2 equal 0. In this case, this is going to only happen I gotta go back. I wrote something around there wrong. We need to know when this x is equal to 0. That's not going to be in my domain. But we also need to see, I thought I wrote my denominator, I wrote 1 over x, and then we have to figure out where 1 over x equals 2 equals 0. We don't want this to be 0 either, but that would happen when we have, if I multiply for x and I subtract the -2, and then I multiply -2x is equal to 1. So x is equal to -1/2. That would be the other spot. So like I said, I could reason my way through it, which is 0 can't be in the domain of G, and G is going to be an F. F can't have -2, so I have to figure out also where G is equal to -2. And I take those from the domain. Or, as we were doing, I just leave it like this and I go, okay, so we have a fraction here with a denominator and with x in the denominator. X can't be 0 here. This is another denominator that can't equal 0, and that happens when x is equal to -1/2. So we still get that same domain. And from there, I can finally simplify. So all I'm going to do is, because we got x in that denominator, we're going to clear the fraction by multiplying everything by x. So we have 4x is equal to 1 plus 2x. We just answer this part. So worksheet number 5. You have the function 2 over x minus 3, and then you have x squared minus 3x plus 5, and we want to find the domain. So we already saw this the first way when I found the function values. Here, we're going to find the domain the other way, which is this is all real numbers. So that's all we have to worry about, is that this is all real numbers. Here, my domain is that it's everything except that x cannot be 3. So what I need here is that G is going to be inside of F. That means I also need to find when g of x is going to be equal to 3. So that's another way to think your way through that. Sorry, there was an interruption. So if I do that, we're going to get a polynomial, which is set equal to 0. You see, we pretty much are getting what we had last time as we did the same thing. So this only happens when x is equal to 1 or 2. So here, what we see here is if x equals 1 or 2, then g of x will end up equaling 3. This is what we're going to get there, because that's what we started, gx equals 3. So if x is 1 or 2, then g of x is equal to 3. And therefore, f g of x is going to be undefined. So when we do our domain is all real numbers except x cannot be 1 or 2. So if we do a similar thing here, now we have g is the inside function and f is the outside function. So g is composed everywhere, but f we only have to worry about as when x is equal to 3. So g is defined for all real numbers. So that means that g is defined for all f of x. So no matter what f of x outputs out of f is going to work in g. So the only thing we have to worry about is that this didn't work in f, therefore it's not going to work in the composition. So the domain here is x cannot be 3. And then this one, because we're composing the function with itself, we have the situation where x can't be 3 because f of 3 is undefined. But also, if we do this composition here and we put f is here as well, so we need to figure out f of x is undefined if f of x also equals 3. We need to figure out when f of x would be equal to 3. So if we multiply both sides, we end up with 3x minus 9 equals 2. So we end up with 0 of 3x equals 11. So we would get there is x can't be 11/3 also. So here my domain is x cannot be 3 and it cannot be 11/3. So I believe I missed 11/3 the first time we did this. Just to go back, when you do number 4, just a reminder, also 11/3 would be taken out. Here we got the square root of x squared plus 5, and we want to now take this and write it as two functions. So this is called what we call a decomposition of functions. So when we have a decomposition of functions, what we're trying to do is figure out what two functions do we have here. So we have the square root, and then we have this x squared plus 5 inside of it. So one of the first things we might want to do is just rewrite it, and we'll just say this is actually the square root of g of x, and we're going to say that g of x is actually x squared plus 5. So it's kind of a substitution method. We do use this later on in other parts of course, that we might substitute a function for another for just a function name. So instead of saying we have x squared plus 5, well, we're just going to call that g now. So now we need something that explains that square root. So let's say we have fx explain a square root. So we can have fx is just going to be a square root of x. So we could say that h of x is actually just f of g of x, which is square root of g of x, which is then just going to be the square root of x squared plus 5. So my two functions are f of x equals x squared plus 5, g of x, oops, I did that backwards. F of x is square root of x, and g of x is x squared plus 5. And then we have that h of x is actually just f composed with g. So try number 6. So bear in mind that you can actually write a composition of functions more than one way. There's not just one set way. The easiest thing to do is to find what looks like a function that's inside of another function and then try to pull it apart. Okay, so I'm going to do two different decompositions here. So I'm going to do the more classic one. So this is the one that you should be doing, but it can show you that there is more than one way. So if we look at this, looks like we can say this is another function inside of some functions. We can call this g of x. So we'll just say h of x is just going to be g of x squared minus 5, where g of x is actually just 2x minus 3. So now we need a name for this outside part where we have something squared minus 5, so we're going to call that f of x. So f of x will just be the x squared minus 5. So all I'm doing is I'm taking this part here and just replacing g of x with x. So I have two functions. And your h of x is just the composition of f composed with g. So your two functions would be g of x, which is 2x minus 3, f of x, which is x squared minus 5. Like I said, there's another way to do it. You could just say, maybe it's just this segment here, that's going to be my g of x. Not the best way to do it, but we would have h of x would then be g of x minus 3 squared minus 5, with g of x just being the 2x. So if I just remove that g of x and replace it with x, then f of x is just going to be x minus 3 squared minus 5. So like I said, that is another way to do it, but definitely this is the way your homework's going to see it. Just wanted to point out that decomposition of functions can work in several different ways, especially if you go on to doing something like calculus. You might have to decompose something in a particular way that is more beneficial to you.